In this video, we're going to solve nonlinear systems of equations by using the strategy of substitution. So if you look at this first system here, you'll notice I have two nonlinear systems because they both contain an x squared. Those are both quadratics. And the instructions here are telling me to use the substitution strategy. Now, if I think back to when we talked about substitution in the past, what we were trying to do is we were trying to replace a variable in another equation with what it was equal to. And what I notice with these set up right here is I have y equals this value and y equals this value. So because I have this y value alone in each equation, this is already set up for substitution. And all I need to do is I need to decide which variable, which y value I'm going to substitute in for. So what I'm going to do is I'm going to focus in and box in this piece right here because y equals this. Y equals negative x squared plus 2x minus 2. And what I'm going to do is I'm going to replace it in place of y in the first equation. So notice I'm replacing y with an entire statement that it is equal to. So what I'm going to do here is I'm going to rewrite this first equation here by replacing y with what it is equal to. So we have negative x squared plus 2x minus 2, and that all goes in place of y, and that's equal to 2x squared minus 4x minus 2. So I've used the substitution strategy to substitute what y is equal to into another equation. And now from here what I notice is this looks a lot like the quadratics that I've seen in the past. And I know with quadratics, what I need to start off doing is I need to get everything together on one side of the equation. So I'm going to start there. I'm going to add x squared to each side. I'm going to subtract the 2x from each side, and then I'm going to add 2 to each side. So here I end up with 0 equals, that becomes 3x squared. That becomes negative 6x. And this just becomes plus 0. So now if I take a look at this quadratic, I start to brainstorm which strategies can be helpful here. And because of this plus 0 on the end, it doesn't really need to be here. I notice that this is a great situation for the greatest common factor factoring strategy. Now you could also use other strategies like completing the square or the quadratic formula, but because I can see that greatest common factor is going to work so well here, that's the strategy I'm going to pick. Again, you can pick what you'd like, but I like the greatest common factor. So I notice the greatest common factor here is 3x, so I'm going to factor out a 3x in front, and that leaves me with 3 divided by 3 is 1, and then there's an x left, so I have x minus, and then 6 divided by 3 is 2, and the x's cancel out. And then I can use the zero product property here because I have something times something equals 0. So I have 3x that can be set equal to 0 and x minus 2 that can be set equal to 0. And then I solve each mini equation and I end up with x equals 0 or x equals 2. Now, the tricky part about this is we're not done. Remember that our solutions when we're solving a system are not just an x value, but our solutions are coordinate points. So what this is telling me is that one of my solutions has an x value of 0, and one of my solutions has an x value of 2. And what I need to do now is I need to take these x values, and I need to figure out what the corresponding y coordinates are. I need to take the time to calculate those. And the best way to calculate those is to take these two x values and put them back into one of these two equations. It doesn't matter which equation because regardless of the equation we put it in, it's going to produce the same values because we're finding the coordinate points where these two equations cross, but we need to plug them back into one of them. So you can pick whichever equation you'd like. I'm going to pick this first one here just because it's the first equation. So let's start with the x equals 0 number. And if we plug in x equals 0, we have 2 times 0 squared minus 4 times 0 minus 2. Well, this becomes 0 minus 2, which is a negative 2. So the other coordinate when x is 0, y is negative 2. And then if we repeat this process with the other x value of x equals 2, we find that we have y equals 2 times 2 squared minus 4 times 2 minus 2. So this becomes 2 times 4 minus 8 minus 2, which becomes 8 minus 8 minus 2, which is 0 minus 2, which is negative 2. So our second coordinate here is x is 2, y is negative 2. So here we have found the 2 points where if we were to graph these two quadratic parabolas here, these are the 2 points where those two quadratic parabolas would cross. So if we take a look here at this nonlinear system, we notice we have one nonlinear equation and one linear equation because this second one here doesn't have any squareds in it. So if we're going to utilize substitution, what we need to do is we need to set this up for substitution by getting a variable by itself. So I'm going to start by getting this y value alone because I know I can get y alone pretty easily by adding 4 to each side. So here we would have y equals negative x plus 4. Now, what you also need to know is that you can get the x alone as well if you'd like and do it that way. You have to just start off by dividing everything by a negative 1. So I chose to get y alone, but it doesn't matter which variable you get alone as long as you can get it alone pretty easily. So now that I know what y is equal to, I'm going to take what y is equal to and I'm going to substitute it back into this original equation here. So if I substitute that in, I have x squared plus, because I have this whole thing for y, I'm going to put it in parentheses. So I have negative x plus 4 quantity squared is equal to 16. So again, I started off by getting my variable alone, and I substituted it into the other equation in place of y, because negative x plus 4 was equal to y. Now from here, I need to deal with these parentheses because I can't really solve this when I have x inside of and outside of parentheses. I also need to remember that negative x plus 4 quantity squared is really negative x plus 4 times itself. So I'm going to start off by writing that first. And then from here, I know that I need to multiply this set of parentheses out. So I have negative x times negative x, which is going to become negative 1 times negative 1, which is a positive 1. X times x is x squared. Then I have negative x times 4, so that's minus 4x. 4 times negative x, which is minus 4x. And I have 4 times 4, which is 16. So then here, if I continue to simplify this, I end up with 2x squared minus 8x plus 16 equals 16. I then subtract 16 from each side, and I end up with 2x squared minus 8x is equal to 0. Now again here, we could use the greatest common factor strategy if we wanted to, but because I want to practice using a lot of different strategies here, I'm going to choose to use the quadratic formula here to help me find the x values that make this particular equation true. So again, you can use greatest common factor here for this one, but I'm choosing to use quadratic formula just to show you another strategy you could use. So here we start off by taking x equals, and negative b is minus negative 8, plus or minus the square root of negative 8 squared, and then it's plus a negative 4 times a, which is 2, times c, which is 0. And then that's all divided by 2 times 2. So this becomes a positive 8 plus or minus the square root. And if I take negative 8 squared plus negative 4 times 2 times 0, I end up with 64 underneath that square root. And then 2 times 2 gives me 4. So then here I have 8 plus or minus the square root of 64 is 8 over 4. So then if I split it into the positive and negative answers, I have 8 plus 8 divided by 4, which is 16 over 4, which gives me my first x value of x equals 4. And then if I do the same thing over here, 8 minus 8 over 4, that becomes 0 over 4, which becomes the other x value of x is equal to 0. So I have found my two x values here, and remember, those x values are a part of my solutions. They are the x coordinates where these two equations cross. So I'm going to put 4 in for x and 0 in for x here. And I'm going to then find my y values. And what I'm going to do here is I'm going to utilize this equation because if I know what x is, I can simply substitute x in and very, very quickly find y. So here I'm going to start with x equals 4. And if I plug that in there, I get y equals negative, and then that's 4 going in for x plus 4. So that turns into negative 4 plus 4, which is 0. So when x is 4, y is 0. And then when x is 0, so I have y equals negative 0 plus 4, well, that turns into 0 plus 4, which is 4. So when x is 0, y is 4. So here I have my 2 points where these two equations will cross.